Hi, my name is Moira. Hi, my name is Aisha. Hi, my name is Shakina. Hi, my name is Amira.
Hi, my name is Usna.
Hello, my name is Anissa.
Definition of colloid. Colloid is a dispersion of particles of one substance throughout a dispersion medium made of another substance. So, the keyword for the definition of colloids are disperse phase and dispersion medium. Based on the diagram below, the red dot will act as a disperse phase, meanwhile the solution will act as a dispersion medium. Colloid particle size. Colloids are distinguished from another form of suspension by the size of the disperse phase particle. Colloidal particles are any substance. Those have diameter of the order of 1 until 100 nanometer. Second, smaller that cause can be seen under microscope, will settle under the action of gravity. Third, colloidal solutions are generally referred as sols. If the dispersion medium is water, it will call as hydrosol or aquasol. If more concentrated colloidal solution, it can be referred as gels or hydrogels if aqueous. Next, filterable particles but larger than atoms and small molecules, and they pass the pore of the ordinary filters. Lastly, invisible in ordinary microscope. Definition of true solution. True solution is a homogeneous solution in which the solid particles have diameters less than 10 power of negative 9. The solid particles are of molecular dimension. The particles are invisible under powerful microscope such as sodium chloride in water. Particles of true solution cannot be filtered through filter paper and are not visible to naked eye. Definition of suspension. Suspension is a heterogeneous mixture in which one or more components have a particle size greater than 10 power of negative 7. Very often, these particles are visible to the naked eye. For example, sand in water, sodium chloride in benzene, and also turmeric in water. Next is the definition of colloids. Colloids is a solution in which the particle size range between 10 power of negative 7 and 10 power of negative 9. Example, milk, blood, honey, smoke, ink, gum, and also starch solution.
Eight types, which is liquid aerosol, solid aerosol, foam, gels, solid foam, solid soap, salt, and then emulsion. Colloid solution provided three things, which is particles are dispersed or spread throughout the dispersion medium, such as water. The second one, which is the size of colloid particles, is intermediate between the coarse suspension and ordinary solution. And the last part, which is the size of particle is small, where randomly collision keep them dispersed throughout the dispersion medium, and neither sink to the bottom nor dissolve in the solvent. In liquid aerosol, when in dispersion medium, which in gas, when in dispersed phase, which in liquid. The example of that which is insecticide spray, liquid spray, mist, fog, and cloud. This is cloud. In solid aerosol, when in dispersion medium, did not require. When in dispersed phase, which in solid. The example of the solid aerosol which is smoke, dust, smoke after exhaust. This is a smoke. In form, the dispersion medium which in liquid, and the dispersed phase which in gas. The example of that which is form or salt solution, bubbles on drink, aspiration form, vapor cream, and shabby leather. This is vapor cream. In emulsions, which in dispersion medium which in liquid with fat, and the dispersion phase which in liquid which is water. The example of that which is milk, mayonnaise, cosmetic lotion, and salad dressing. This is milk and this is mayonnaise. In salt, the dispersion medium did not require, and the dispersion phase which in solid. The example of that which is paint, toothpaste, lard, starch, custard, pigmented ink, detergent, lettuce, and mud. This is a lard and this is paint. In solid form, is in dispersion medium, is in solid, and dispersed phase which in gas. The example of that which is aerogel, ice cream, bromide, marshmallow, scaffold, insulation, cushion, and sponge. This is ice cream, marshmallow, and sponge. In solid emulsion, when the dispersion medium did not require, when in dispersion phase, which in liquid. The example of that which is opal, pearl, silica gel, butter, cheese, jelly, agar, and pudding. This is a pudding. This is a cheese.
Colloid is divided into two, which is lyophilic and lyophobic. Lyophilic means it loves liquid, it has high affinity towards solvent, and it can combine chemically or physically with solvent. Lyophilic colloid have intermolecular attraction between the dispersed phase and dispersion medium. It is thermodynamically stable colloidal dispersion, and this is due to strong attractive forces between particles and dispersion medium, for example hydrogen bonding, and this is not easily coagulated. Next, lyophobic colloid. It hates liquid, and the particle resists solvation and dispersion in solvent. Lyophobic colloid have no intermolecular attraction between the dispersed phase and dispersion medium. It is thermodynamically unstable compared to separated states. The dispersion can be formed with mechanical energy input, for example, mixer, colloid mill, and ultrasound generator. The stability is due to charged particles and the like charges repel each other, which avoid coagulation. There are some differences between lyophobic and lyophilic. First, lyophilic is solvent-loving, while lyophobic is solvent-hating. Next, lyophilic is precipitated by high concentration of electrolyte, while lyophobic is precipitated by low concentration of electrolyte. Next, lyophilic interacts strongly between dispersed phase and dispersed medium, while lyophobic has no interaction between dispersed phase and dispersing medium. Next, lyophilic has little or no charge on particles, while lyophobic particles carry positive or negative charge. Next, lyophilic has particles that migrate to either anode, cathode, or not at all, while lyophobic particles migrate to either anode or cathode. And lastly, lyophilic has high viscosity of dispersing medium, which easily set to gel, while lyophobic has viscosity is no different from pure liquid, which do not set to gel.
Now I will explain about the preparation of colloidal solution. Lyophilic solution can be prepared by stirring the solid with the dispersing medium such as water, while lyophobic solution can be prepared by dispersion method or condensation method. For dispersion, there are three methods, which is mechanical dispersion, baptization, Briggs arc method. Where for condensation, there are five methods, which is solvent exchange, double decomposition, hydrolysis, oxidation, and reduction. The first is mechanical dispersion. Mechanical dispersion is the substance to be dispersed is suspended in the dispersion medium and the ground to final state by mechanical means. For example, when you're trying to beating the white of an white egg. Next is baptization. Baptization is a freshly prepared precipitate of the substance is made to pass into colloidal state by the addition of a suitable electrolyte. The electrolyte added is called baptizing agent. As you can see here, we have precipitate of ferric hydroxide and added into ferric chloride. The ferric chloride will dissociate it into ferric ion and chloride ion. The precipitate will attract the ferric ion on its surface. It will then, the positive ion will start repelling each other and it will cause the large particles of precipitate breaks down into small particles of colloidal. So this is the setup for Briggs arc method. These methods are mainly used for the preparation of metals such as silver, gold or platinum. And electric are stuck between the two electrodes. The electric current are passes to the electrodes to create electric arc. The vessel containing the water may be surrounded by a freezing mixture if necessary. The high temperature of the arc will vaporize some of the metal, and then the vapor will condense to the particle of colloidal size while cooling. The addition of alkali to the conductivity water helps to get more stable colloidal solution, which can be freed from particles of non-colloidal size by filtration. Now I will explain about the condensation method. The first is solvent exchange. For example, a few drops of ethanol solution of oleic acid are stirred with 100 ml of distilled water. Acid will insoluble in water and form milky-looking suspension. The addition of water to sulfur ethanol solution causes the formation of colloidal sulfur due to sulfur is less soluble in water. Next is hydrolysis. Colloidal form when the substance is react with water or we call as hydrolysis process. The third method is oxidation. Oxidation is a reaction involving oxidizing agent. For example, sulfur solution are readily prepared by adding hydrogen sulfide gas in aqueous solution and various oxidizing agents. Last but not least is reduction. Reduction is a reaction involving reducing agent. For example, silver solution and gold solution can be prepared by treating dilute solution of silver nitrate and auric chloride with organic reducing agent like iron sulfate and organic agent like formaldehyde.
First, Tyndall effect. When a beam of light is thrown against a colloidal solution, the path of the beam is illuminated as a result of the scattering of light by the particles, and a blue cone known as a Tyndall cone is observed. The Tyndall effect is caused by reflection of light by very small particles in suspension in a transparent medium for any particle size. Tyndall effect will increase linearly with concentration. This is the example of the Tyndall effect. Movement. The colloidal particles in solution are in state of constant and rapid zigzag motion called Brownian movement. The result of random collision with the molecules of the suspending medium are the particles and the walls of the containing vessel. The higher the temperature, the more vigorous is the movement of the molecules. Particles of a colloidal solution possess either positive or negative charge. If a colloidal solution is placed in a U-tube and potential difference applied at its two ends, the charged particles are seen to move towards the opposite electrode. This movement to the charged particles under the influence of an electric field is known as electrophoresis. Coagulation. Addition of electrolytes causes the precipitation of the colloidal particles because the charged ion of the electrolyte neutralizes the charge on colloidal particles.
Adsorption. Adsorption is a process in which a substance becomes attached to the surface of a solid or liquid. This process must be distinguished from adsorption, in which the substance becomes distributed throughout the solid or liquid. Examples: activated charcoal adsorbs gases like CO2, SO2, and Cl2. Platinum or nickel metal kept in contact with a gas absorbs the gas. Example, hydrogenation of oils. Animal charcoal, when added to acetic acid solution and shaken vigorously, adsorbs acetic acid. Molasses is decolorized by activated charcoal. Now, there are 4 factors affecting adsorption. First, nature of adsorbate and adsorbent. Second, the surface area of adsorbent. Third, activation of adsorbent. And fourth, experimental condition, as an example, temperature and pressure. There are 2 types of adsorption: physical adsorption and chemical adsorption. Physical adsorption. Heat of adsorption less than 10 kilocalorie per mole. Occur at temperatures below the boiling point of the adsorbate. The incremental increase in the amount adsorbed increases with each incremental increase in pressure of the adsorbate. The amount of adsorption on the surface is more function of the adsorbate than the adsorbent. No appreciable activation energy is involved in the adsorption process. Multilayer adsorption occurs. Chemical adsorption. Heat of adsorption greater than 20 kilocalorie per mole. It occurs at high temperatures. The amount of adsorption is characteristic of both adsorbate and adsorbent, and activation energy may be involved in the adsorption process. The incremental increase in the amount adsorbed decreases with each incremental increase in the pressure of the adsorbate. adsorption leads to, at most, a monolayer. Now, what is monolayer adsorption? In monolayer adsorption, all the adsorbed molecules are in contact with the surface layer of the adsorbent. What is multilayer adsorption? In multilayer adsorption, the adsorption space accommodates more than one layer of molecules, and not all adsorbed molecules are in contact with the surface layer of the adsorbent. Adsorption isotherm. Isotherm is an equation which relates the amount of substance attached to the surface to its concentration in the gas phase at a fixed temperature. A relationship between X over M and the equilibrium concentration of solution or pressure of gas of the adsorbate at fixed temperature is called adsorption isotherm. This may be obtained experimentally by determining X over M as a function of C or P, Langmuir for monolayer adsorption and BET for multilayer adsorption. Langmuir isotherm. In 1916, Irving Langmuir published a new model isotherm for gases adsorbed to solids. It is a semi-empirical isotherm derived from a proposed kinetic mechanism. Langmuir isotherm describes a single layer which is monolayer adsorption, which the volume of gas molecule adsorbed at certain pressure. This isotherm was based on different assumptions, one of which is the dynamic equilibrium exists between adsorbed gases molecules and the free gases molecules. The amount of adsorbate at a given temperature is measured as a function of gas pressure P in equilibrium with the solid adsorbent at constant temperature and called adsorption isotherm. Rate of adsorption is proportional to the concentration of the adsorbed molecule, which is proportional to the applied pressure. Brunel, Emmett and Taylor isotherm, BET. Multilayer adsorptions also occur especially in physical adsorption. BET isotherm is used to explain the multilayer adsorption. The adsorption process can be described in terms of the attachment of molecules directly on solid surface, the attachment of molecules to sites already occupied adsorbed molecule forming the second layer. The build-up layers can continue until, as the gas pressure approaches the vapor pressure of the gas, the adsorption has reached the stage where the surface could be described as wet, due to vapor condensation as the pressure increases.